part 3 is really the weird part, okay? That's the part which stops everyone, but enough people got stopped by parts 1 and 2 that I figure I might as well just go back over those as well, okay? So, if you got the paper there, or at least where you did your working, here's where you start. You get given the standard equations of motion for your projectile motion. And what you've got to prove is the equation of path, okay? So do you remember how to do this? Even if you don't remember anything about projectile motion, you have a look at what this is. This is an equation between y and x. So what you've got to do is eliminate your parameter, t, okay? And the way you're going to do it is you want a y equals equation, okay? So the stuff from here is going to go into here and not the other way around, okay? So being that I want to eliminate my parameter, okay, I'm going to make the parameter the subject of this first equation. So if I take the x equation, what's t going to be equal to from that equation? Yeah, good. Okay, so now that we have established that, all we need to do is sub this, call that 1, into this, and it'll fall out, okay? But because it's all in, the result is given, all of the marks are in the process you go through to get there, okay? So let's go ahead and do it. When I sub in my x on v cos theta, I'm going to have one of them up the front here, squared, right? There's my t squared. And I'm going to have the other one here. Sine theta. Okay. Now again, because it's a show, it's a prove, it's a demonstrate kind of question. Okay. You can't go ahead and skip steps, right? So you can't go from here to 1 plus tan squared theta, even though it's true. Okay. We've got to make the identities clear. So let's go ahead and do that. You're going to have your minus. Put the g on 2 there. X squared. I put these out separately just so I can make it more obvious. And this is your sec squared theta, right? Okay, you've got to have that step, okay, because that's where you get this identity from. Then here, v's cancelled, that's okay, and you got sine theta and cos theta, that's all right. There's no intermediate step between sine theta and cos theta and tan. Okay, so you're going to have your x tan theta there, and that part's done, which is nice. Okay, I'll stick that out the front because it's in the front in what they want us to produce. And I want to start to rearrange this business because I want to get it towards that, where h is, what is it? It's like 2v squared, no, hold on. V squared on 2g, right? Yeah, sorry, that's right. Okay, so if I want to get towards that, I want to have that nice and clear out the front. And I have to have it upside down. It's just slightly awkward, but it'll be useful later, okay? So what am I going to have? I've got my minus g on 2v squared, x squared, and now I can turn that into my 1 plus tan squared, okay? Okay, now I think that's basically enough. I mean, you can see here where this is going to go, and they've provided that value of h to you. Okay, so I think it's enough to then give the provided value. What did I do? I threw an extra. Hold on, what did I know? Did I forget to write that? Is that what I forgot?
Yeah.
Yeah, that's right. That's better. Okay. 1 plus. That's non-h. Okay, now, you may ask the question, why did they bother asking us to prove this given result of 2 other given results when it's like, well, you know, are they just trying to pad out the number of marks? And the answer is no, they're trying to give you a clue for questions 2 and 3, okay? Now, the equation of path is useful to us, right? Because it reframes a question which is about different kinds of velocities into just a Cartesian sort of problem. Okay? So in other words, it's a quadratic. And we know heaps about quadratics. Okay? But the interesting thing about this kind of quadratic is that it's 2 quadratics at the same time. Can you see it? It's a quadratic in x. That's the obvious one, because you've got your, one solution here, another solution there, depending on where you find from, right? But you can see it's also a quadratic in, if I stick y here, you've got your tan squared and your tan theta there. That's why, why do they bother? Why not just leave it as sec squared? That's fine, isn't it? Well, it's to try and make it more obvious that it's a quadratic in tan theta, okay, which becomes crucially important in parts 2 and 3. And also part 2. All right, so there you go. There's part 1. There's your equation of path. Let's keep moving through.